Apply versus transform on a group object. Consider the following data frame. The following commands work, but none of the following work. Why? The example on the documentation seems to suggest that calling transform on a group allows one to do row-wise operation processing. In other words, I thought that transform is essentially a specific type of apply, the one that does not aggregate. Where am I wrong? For reference, below is the construction of the original data frame above.
Two major differences between apply and transform. There are two major differences between the transform and apply grouply methods. Input. Apply implicitly passes all the columns for each group as a data frame to the custom function, while transform passes each column for each group individually as a series to the custom function. Output. The custom function passed to apply can return a scalar, or a series or data frame, or NumPy array or even list. The custom function passed to transform must return a sequence, a one-dimensional series, array or list, the same length as the group. So, transform works on just one series at a time and apply works on the entire data frame at once. Inspecting the custom function. It can help quite a bit to inspect the input to your custom function passed to apply or transform. Examples. Let's create some sample data and inspect the groups so that you can see what I am talking about. Let's create a simple custom function that prints out the type of the implicitly passed object and then raises an exception so that execution can be stopped. Now let's pass this function to both the grouply apply and transform methods to see what object is passed to it. As you can see, a data frame is passed into the inspect function. You might be wondering why the type, data frame, got printed out twice. Pandas runs the first group twice. It does this to determine if there is a fast way to complete the computation or not. This is a minor detail that you shouldn't worry about. Now, let's do the same thing with transform. It is passed a series, a totally different pandas object. So, transform is only allowed to work with a single series at a time. It is impossible for it to act on two columns at the same time. So, if we try and subtract column A from the inside of our custom function, we would get an error with transform. See below. We get a key error as pandas is attempting to find the series index A which does not exist. You can complete this operation with apply as it has the entire data frame. The output is a series and a little confusing as the original index is kept, but we have access to all columns. Displaying the past pandas object. It can help even more to display the entire pandas object within the custom function, so you can see exactly what you are operating with. You can use print statements by I like to use the display function from the IPython.display module so that the data frames get nicely outputted in HTML in a Jupyter notebook. Screenshot. Transform must return a single-dimensional sequence the same size as the group. The other difference is that transform must return a single-dimensional sequence the same size as the group. In this particular instance, each group has 2 rows, so transform must return a sequence of 2 rows. If it does not, then an error is raised. The error message is not really descriptive of the problem. You must return a sequence the same length as the group. So, a function like this would work. Returning a single scalar object also works for transform. If you return just a single scalar from your custom function, then transform will use it for each of the rows in the group.
As I felt similarly confused with .transform operation versus .apply, I found a few answers shedding some light on the issue. This answer, for example, was very helpful. My takeout so far is that .transform will work, or deal, with series, columns, in isolation from each other. What this means is that in your last 2 calls, you ask .transform to take values from 2 columns and it actually does not see both of them at the same time, so to speak. Transform will look at the data frame columns one by one and return back a series, or group of series, made of scalars which are repeated len input underscore column, times. So this scalar, that should be used by .transform to make the series is a result of some reduction function applied on an input series, and only on one series/column at a time. Consider this example, on your data frame. Will yield which is exactly the same as if you would use it on only on one column at a time. Yielding. Note that .apply in the last example, df.groupVA.C.applies score, would work in exactly the same way, but it would fail if you tried using it on a data frame. Gives error. So where else is .transform useful? The simplest case is trying to assign results of reduction function back to original data frame. Yielding. Trying the same with .apply would give nans in sum underscore c. Because .apply would return a reduced series, which it does not know how to broadcast back. Giving. There are also cases when .transform is used to filter the data. I hope this adds a bit more clarity.
I am going to use a very simple snippet to illustrate the difference. The data frame looks like this. There are 3 customer IDs in this table. Each customer made 3 transactions and paid $1, $2, $3 each time. Now, I want to find the minimum payment made by each customer. There are 2 ways of doing it. Using apply. Grouping.min. The return looks like this. Using transform. Grouping.transform min. The return looks like this. Both methods return a series object, but the length of the first one is 3 and the length of the second one is 9. If you want to answer what is the minimum price paid by each customer, then the apply method is the more suitable one to choose. If you want to answer what is the difference between the amount paid for each transaction versus the minimum payment, then you want to use transform, because apply does not work here simply because it returns a series of size 3, but the original DF's length is 9. You cannot integrate it back to the original DF easily.
Is like. Or.